Dear students, I am Tanmoy Ghosh, Assistant Professor, Mechanical Engineering Department, Sri Ramakrishna Institute of Science and Technology. Today, I discuss introduction and basic concepts of fluid mechanics. At first, we should know it why to study fluid mechanics in mechanical engineering. Fluid mechanics is one of the basic courses in engineering. It is a bridge course between what you have already studied in physics. Dairy plants handle various types of fluids such as milk, water, air, refrigerants, steam, etc. It is very important to learn the behavior of fluid under various conditions. In order to design the system for handling of such fluids in dairy plants. Fluid mechanics is a branch of engineering science, the knowledge of which is needed in the design of water supply and treatment system, pumps used for handling of different fluids, piping system for various utilities, pipe fittings and valve, flow meters, etc. Ships, submarines, aeroplanes, automobiles, storage tanks like as milk silo, tankers, feed tanks, balance tanks, etc. Measuring instrument, heat transfer behavior in processing equipments such as HTST, pasteurizers, spray dryers, etc. Cleaning in place CIP for optimum performance. Now, fluid mechanics. There are two words, fluid and mechanics. The definition of fluid come to the next. And what is mechanics? The branch of applied mathematics that deals with the motion and equilibrium of bodies and action of forces. And what is fluid mechanics? A branch of science that studies the mechanics of these free moving particles. Fluid mechanics are three categorized: fluid statics, fluid kinematics, fluid dynamics. Statics means in rest condition. So, study of fluid in rest is called fluid statics. On the other hand, fluid kinematics, study of fluids under motion, velocities and acceleration come to the in kinematics. Fluid dynamics, study of forces and their analysis causing the fluid motion or deformation. Fluid mechanics is the study of fluids at rest or in motion and interaction of fluids with other fluids or solids at boundaries. There are several definitions of fluid. Firstly, fluid is a substance which continuously deforms under applying of shear stress, no matter how small the shear force may be. Secondly, fluid is a substance that can't sustain shear force when it is at rest. And third position, however, in fluid flow, there exist shear stresses between adjacent layers which result in opposing the movement of one layer over adjacent layer. Generally, gases and liquids are the fluids. Liquids, practically incompressible or non-compressible, occupies definite volume, non-affected appreciably by temperature and pressure change. On the other hand, gases are compressible, occupies the volume of vessel greatly affected by temperature and pressure. Now, ideal fluid. A fluid is said to be ideal if it is assumed to be zero viscosity, zero surface tension and incompressible. In reality, there is no exist in ideal fluid. Now, real fluid. A fluid is said to be real if it has viscosity and finite compressibility and surface tension. Now, concept of continuum. This concept means that there are no voids or empty spaces in the distribution of matter. Fluid is considered as a continuum as even in case of gases, density is very high and the distance between successive collisions of the molecules is very small, means that free path of the molecules much less than system dimensions. However, when the mean free path of the molecules become the order of the system dimension, then this concept loses its validity. No slip condition. It's due to the viscosity of the fluid. Fluid in direct contact with the boundary acquires the velocity of the boundary, which means fluid sticks to the solid and have zero velocity or no slip at the contact point. Now, types of fluid. There are two types of fluid. One is Newtonian and other non-Newtonian. Now, non-Newtonian fluid are then two categorized, time independent and time dependent. The fluid which obeys the Newton's law of viscosity, that means tau equals to A du dy to the power n plus v, is called Newtonian fluid, and the fluid which does not obey the Newton's law of viscosity, that means tau equals to A du dy to the power n plus v, is called non-Newtonian fluid. The relation between shear stress and velocity gradient of this, that means tau and du dy, and where A and B are constants depending upon type of fluid and condition of flow. Non-Newtonian fluid are two categorized, time independent and time dependent. Time independent fluids are dilatant fluids, Bingham plastic fluids, pseudoplastic fluid. Dilatant fluids n greater than 1 and b equals to 0. Example, butter, quicksand, Bingham plastic fluid. N equals to 1 and b not equals to 0. The example of the Bingham plastic fluid, sewage sludge, drilling mud, toothpaste and gel. And pseudoplastic fluid, example of the pseudoplastic fluid, paper pulp, rubber solution, lipsticks, paints, blood. On the other hand, time dependent fluid, thixotropic fluids and rheopectic fluids, n less than 1 and b not equals to 0. Here, viscosity increases with time. The example of the thixotropic fluids, printers, ink and enamels. Rheopectic fluids, n greater than 1 and b not equals to 0. Here, viscosity decreases with time. Example of the rheopectic fluids, gypsum solution in water and bentonite solution. Now, this is a diagram, shear stress versus velocity gradient. In this diagram, various types of fluid shows. On the top of this diagram, there is a little convex curve named thixotropic fluid, and the bottom of this diagram there is a dilatant fluid and concave in nature and time independent fluid. Now, some physical properties of fluid. Density, mass density. Symbol of density or mass density is rho. It is defined as mass per unit volume at stated temperature and pressure. It is also known as specific mass. Density rho equals to mass per unit volume. That means rho equals to m by v. The unit of the density or mass density equals to kg per meter cube. Specific weight or weight density. The symbol of this specific weight or weight density is W. It is defined as weight per unit volume at stated temperature and pressure. Therefore, specific weight W equals to weight per volume. That means W equals to caps W by V. Unit of the specific weight or weight density equals to Newton per meter cube. Specific volume. Vs. It is the volume occupied by the unit mass of a fluid. Specific volume V suffix S equals to volume by mass. অতএব Vs equals to V by M. Unit of the specific volume meter cube per kg. Last, specific gravity S. It is defined as the ratio of specific weight of the fluid to that of the pure water of 4 degrees centigrade. Let small w equals to specific weight of the fluid. Small w of water equals to specific weight of the water at 4 degrees centigrade. Therefore, small w equals to capital W by V, or small w equals to, as weight equals to m into g, mass into gravitational acceleration. So, small w equals to m into g by v, or small w equals to m by v into g. Rho equals to m by v. So, w equals to rho into g. So, come to the definition. S equals to small w by small w of water, or S equals to rho into g by rho w into g, or S equals to rho by rho w. Therefore, S equals to small w by small w of water equals to rho by rho of water. Dear students, wait for the next video and thank you.